Welcome back. Today, we in this class we will discuss the control chart for non-conformities. There are two types of control chart under this case. They are C chart and U chart. And in both the control charts, we will be monitoring the number of non-conformities or defects. In C chart, we will monitor the number of defects per a unit, per a single inspection unit. Whereas in U chart, we will monitor the average number of defects per unit of a sample of inspection units. Okay. When do you say that a unit is defective? A unit is classified as defective unit or non-conforming unit when it contains a number of non-conformities or defects. If the number of non-conformities or number of defects exceeds a limit, you have to classify it as bad, it as defective, it as not good. Okay, but even if a unit have only a few non-conformities or defects, you need not classify it as a bad product or a defective product. Okay, and when we were discussing P chart and NP chart, we were monitoring the number of defectives or non-conformities. Defectives or number of non-conforming units. Whereas in this discussion, we shall monitor the number of non-conformities or number of defects. Okay. In C chart, we will monitor the number of defects or non-conformities per a single inspection unit, in a single inspection unit. Okay, and I have discussed the difference between defects and defectives or non-conformities and non-conforming items with the help of a computer unit example. You may go through this example. Now we come to the construction of C chart along with the statistical basis of a C chart. Okay, you consider the occurrence of non-conformities in an inspection unit of product, and we shall discuss later by considering the non-conformities, average number of non-conformities per an inspection unit by taking a sample of inspection unit. That we will do later. Here we consider a single unit of product and we count the number of non-conformities or defects in that unit. And you suppose that X is the number of defects in an inspection unit. And that X, the number of defects in an inspection unit, will follow a Poisson distribution. The assumptions of a Poisson distribution, the chance for defects are very small, and the area of such defects are very large. Okay, and you know that the X has mass function probability that X is equal to e to the power of minus c to the power of x by x factorial, where x takes the value 0, 1, 2, 3, etc., where c is the parameter of the Poisson distribution. Actually, C is nothing but the mean and variance of the Poisson distribution. Mean and variance are equal for Poisson distribution. So, if you take C as the parameter of Poisson distribution, mean is C and variance is also C. Okay. And here, in this statement, probability that x takes the value small x, where what is x? Small x is the number of non-conformities. Okay, and the C is of course the parameter of the Poisson distribution. Okay, and you know how a control chart can be constructed for a charting statistic. Here the charting statistic is the number of defects. Okay, and you have to take the average number of, that is x. So average number of defects is C here. So by the rule of control charts, center line, for a Schwarz control chart with 3 sigma limits, it will be equal to LCL is equal to mu x minus 3 into standard deviation of x, which is equal to C minus 3 into root C. Then center line is equal to mu x, that is C, and the upper control limit is equal to mu x plus 3 sigma x, that is C plus 3 into root C. This is because of the fact that mu x equal to C and variance of x is also equal to C. So standard deviation is root C. So this parameters are written inconsistent with the usual rule of Schwarz control limits. Here, what is the charting statistic? X. What is x? X is the number of non-conformities. Okay, so using this limits, we can draw the C chart. This is called a C chart. Okay, and here if you set if you have a LCL, while computing LCL, sometimes you can see that LCL is equal to C minus 3 into root of C. It may be sometimes negative. If LCL is negative, you set the LCL is equal to 0. That is the usual rule of constructing LCL and UCL. This is the same thing what we have done in controlling the number of defectives, that is P chart and NP chart. Also the same thing you can do. Okay, and you suppose that this C is available. What is C? C is the average number of defects or non-conformities in a unit. If it is known means a standard in your process, you have already set a standard for your number of defects. That means the case is called standard given case. Okay, and suppose the standard is not given, what you will do? If the standard is not given, that is C is not given, the parameter C is not given or not available, what you have to do? You have to estimate that parameter C using the help of some preliminary units or preliminary, in fact you have to consider preliminary samples, but here a sample consists only one unit, because in C chart we are concerned with a single inspection unit. Okay, and you can estimate C. How would you estimate? You take M units and you count the number of defects in all units, and you add them and you divide it by the sample size. So what is the estimated C? It is equal to C bar. It is equal to C bar. Okay, and LCL is equal to C bar minus 3 in root of C bar. Center line is C bar. UCL is equal to C bar plus 3 into root of C bar. And you remember C bar is equal to x1, that is number of defects in the first unit, plus x2, which is the number of defects in the second unit, plus etc. xm, which is equal to the number of defects in the mth unit, whole divided by m. That is the average number of defects per unit of your preliminary sample of size m. Okay, and an example or a specimen of a C chart is given in the figure given below. You can go to this C chart. You remember along the x-axis, I have written here a sample number, but the sample number, each sample consists only one unit. So this is first sample, second sample, third, fourth, etc. Okay, and the number of non-conformities or number of defects are given in the vertical axis. Okay, and I have plotted all the points in this control chart, and this is only a specimen with UCL is equal to 33.22, LCL is equal to 6.48, and so on. And you see that in this control chart, some of the points here at the 6th sample, a point goes out of control, and at the 19th or 20th sample, or like that, at 20th sample, it goes out of control. And the reason for this out of control situation is also noted here. This is because of a temperature control, and this is sometimes of an inspection error, etc. Okay, now this is only an example, and you will see that the C chart will be look like this. Okay. And as usual, you will have two phases of application. In the first phase, what you will do? First phase, first phase, we will trial control limit ഉപയോഗിച്ച് നമ്മൾ preliminary samples ഇങ്ങനെ എടുത്തുകൊണ്ടിരിക്കും. എന്നിട്ട് ഒരു control limit establish ചെയ്ത് കഴിഞ്ഞാൽ, that will be continued until all the points are in control, and we will use those limits, UCL and LCL, for a stabilized situation for the future purpose. That means we will move to the second phase of application. You remember there are two phases of application for the C chart, as in the case of X bar chart and R chart. In the first phase, we will apply the trial control limits, and once the trial control limits are revised, finally we will be settling with a set of control limits, and those control limits will be used for future monitoring. That is in the second phase of application of control chart. Okay, thank you.